Question 2 on exercise 2.2c. We are asked to find the HCF of the following using index notation. HCF simply means highest common factor, and in order for us to determine the highest common factor between 90 and 300, we shall first of all express 90 and 300 as a product of its prime factors. Thereafter, we look out for the common factors, and the product of the common factors gives us the highest common factor of this. I shall be using two methods, which we refer to as the prime factorization, and one seems to be the higher version of the other. Why I express 90 and 300 in method 1 as the product of their prime factors and therefore comparing them, in method 2 we shall just look for the common factors and use it to divide 90 and 300, and their product gives us the HCF. Method 2 seems to be faster than the method 1, so I shall be using subsequently method 2 in solving others. So method 1, expressing 90 as a product of its prime factors, 2 can divide because the last digit of 90 is said to be divisible by 2, which is 0. So 2 into 9 is 4 remainder 1. This becomes 10. 2 into 10 is 5. 2 can no longer divide 45 because the last digit is not a multiple of 2. So we can test for 3. Can 3 divide? Yes. The rule for divisibility for 3 is that the sum of the digits in that number must be a number that is divisible by 3. So 4 plus 5 is 9, and 9 is divisible by 3. It therefore means that 45 is divisible by 3. So we shall divide by 3. 3 into 4 is 1 remainder 1. This becomes 15. 3 into 15 is 5. So 3 can go into 15 5 times, and 5 into itself is 1. So that 90 can be expressed as 2 times 3 times 3 times 5. We also do same to 300. 2 can go into 300 because the last digit is divisible by 2. 2 into 3 is 1 remainder 1. This becomes 10. 2 into 10 is 5. 2 into 0 is 0. 2 can still divide for same reason. 2 into 15 is 7 remainder 1. This becomes 10. 2 into 10 is 5. But 75 is not divisible by 2 because 5 is not a multiple of 2. So you test for 3. 7 plus 5 is said to be 12. And 12 is divisible by 3. So it therefore means that 3 can divide 75. 3 into 7 is 2 times remainder 1. This becomes 15. 3 into 15 is 5. 3 can no longer divide, for 2 plus 5 is 7 and is not divisible by 3. So therefore test for 5. 5 can divide because the last digit is a multiple of 5. So 5 into 25 is 5 times, and 5 into 5 is 1. So expressing 300 as a product of its prime factors, we have 2 times 2 times 3 times 5 times 5. So looking out for the common factors, we have 2 being common, 3 is common, and 5 is common. So that the HCF is said to be the product of the common factors, which are 2 times 3 times 5. And what would that give us? 2 times 3 is 6. 6 times 5 is 30. So we have it that 30 is the highest common factor of 90 and 300. Just like I said, we shall then look at method 2. In method 2, we shall look for the common factors between 90 and 300 and divide. Now we start with the least, which is 2, because 2 can divide both 90 and 300 because their last digits are said to be divisible by 2. So 2 into 90 is 45. 2 into 300 is 150. Looking at the 2 digits, what is that number that can divide both of them? 2 cannot divide because 2 can divide 150, but 2 cannot divide 45 because the last digit of 45 is said to be 5, which is not a multiple of 2. So we test for 3. Can 3 divide? What is the condition for divisibility by 3? The condition for divisibility by 3 is that the sum of the digits must be divisible by 3. Now, 4 plus 5 is 9, and 9 is divisible by 3. Good. Look at the next one. 1 plus 5 is 6, plus 0 is 6, and 6 is also divisible by 3. So we use 3, which is common. 3 into 45 is 15. 3 into 150 is 50. Can 3 divide again? Yes. 3 can divide 15. No, 3 cannot divide 50, but 3 can divide 50. 15. So 3 can no longer divide. So we look for the next higher factor, which is 5. 5 can divide 15 and 50. Reason being that the rules for divisibility by 5 says that the last digit must be either a 0 or a 5. So since this is 5 and this is 0, it therefore means that 5 can divide. So 5 into 15 is 3 times. 5 into 50 is 10 times. Now, we have 3 and 10. Nothing else can divide. Nothing can go into 3 and 10 without a remainder. So we end it at this point and say that the highest common factor of 90 and 300 is said to be 2 times 3 times 5, which is equal to 2 times 3 is 6, 6 times 5 is 30, which is same thing as what we got here. And if you look out, the highest common factor we got is what we used in dividing in the method 2. So you will discover that method 2 tends to be faster and accurate as method 1. Because in method 1, if you should make a mistake in expressing 90 as a product, each of the number as a product of their prime factors, it will also automatically affect the final answer. So in our subsequent exercises, we shall be using method 2 in solving the HCF of numbers. Kindly like my videos as you watch. While I recommend that you subscribe to my channel on Facebook and on YouTube, also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. While I recommend you share the link with your friends and families so that they can also benefit from our daily classes. We shall now take the next question on exercise 2.2c.